Hey everyone, today we're going to look at two related rates problems for calculus. They're pretty simple. I'm just dumb and took forever to solve them. But anyway, first one is we have the base and height of a right angled triangle is increasing at the rate of 4 and 0.5 respectively. No units, just 4 and 0.5. What will be the rate of change in the hypotenuse when the base is equal to 5 and the height is equal to 12? So, what do we know? Well, we know that 1, base and the height are both increasing, so our answer has to be positive. So let's label this B for base is increasing, plus it's increasing at a rate of 4, just 4 something. It's still a function of time, which is really what matters. And the height is also simultaneously increasing at 0.5. Because I want to label the hypotenuse h, we're going to say the height is a, just for Pythagorean theorem sake. So what we're really looking for is the rate of change, otherwise known as dH on dt. And we know that dB on dt is equal to 4 and dA on dt is equal to 0.5. So how do we do that? Well, they give us some units. Base is 5 and height is 12, so we can first find what the hypotenuse actually is, how long it is at that point. So using the Pythagorean theorem, we get 5 squared, which is 25, plus 144. This is of course equal to 169, and if we take the square root of that, we get 13. So that's our hypotenuse. Now, if we want to take the general form of our Pythagorean theorem, since that's the equation that links all these values together, it's called related rates for a reason, we'll take the general form of that, so we'll have b squared plus a squared. I want to do it this way because it's base and then height. I don't want to do the shorter side first, or at least the one with the lower derivative. And this is equal to h squared. Now if we differentiate, so dt, because these are all functions of time, we would get off chain rule, we get 2b for the derivative of that, multiplied by dB on dt. So let me do that. dB on dt plus 2a multiplied by dA on dt. And this is equal to 2h dH on dt. So, what do we do? Well, we know dB on dt and we know dA on dt. Not only that, we know b and a, at least at specific intervals, so we can plug those values in along with h, because we found that, and that way we can isolate the equation and solve for dH on dt. So, first off, plugging in 10. No, sorry, not 10. 5. 2 times 5 would get you 10, though. So we would simplify this equation now. Essentially, 2 times 5 is 10. 10 times dB on dt, which we said was 4, off right here. So 10 times 4, 40, plus 2a. A was found to be 12. 12 times 2 is 24. And 24 times dA on dt, which we said was 0.5, gets you 12. 12 is equal to h. 2 times 13 is 26. 26, and then we have dH on dt, which we still don't know. Simplify this equation out a little bit, we would eventually get, well, 40 plus 12 is 52. 52 divided by 26 is 2. So we get 2 is equal to dH on dt. We did it. Oh, well, I kind of boxed the wrong thing. dH on dt is equal to 2. So, thinking about this intuitively, what does that mean? Well, for one, like I said, our value has to be positive, and we did get that. So we know for a fact that our hypotenuse, at the very least, is growing, which makes sense with the context of the problem. Simultaneously, it doesn't seem radically large. It's not, 7,000 or something. So, seems to make sense with the context of the problem, and it is in fact correct. Because the hypotenuse has to expand to, well, make a triangle. If it doesn't, it just has empty holes in it, so it expands to touch both the height and the base and maintain the Pythagorean theorem. And by extension, remaining a right triangle, or just like a triangle in general that doesn't have holes in it. So let me erase all this. Now let's move on to problem number 2. Problem number 2 states, for a certain rectangle, the length of one side is always 3 times the length of the other. If the shorter side is decreasing at a rate of 2 inches a minute, at what rate is the longer side decreasing? And part 2 to this question is, at what rate is the enclosed area decreasing when the shorter side is 6 inches long and is decreasing at a rate of 2 inches a minute? So, what do we know? Well, it's a rectangle. How do we find the area of a rectangle? We do length times width, and that's equal to the area of a rectangle. We also know that, in this case, let's say length is the longer side. The longer side is always 3 times the shorter side, which is w, and therefore a rewritten equation would be 3w squared is equal to a. But for the purposes of this, I will leave it as 3w times w equal to, so I'm just going to rewrite everything in terms of w, since we actually know that. So, what do we do now? Well, in order to, let's think about what we're looking for first. We know that dw on dt is equal to -2, because it's decreasing. So we're essentially looking for dl on dt. But remember, the length, if we decide for that to be the longer side, is just always 3 times the length of the shorter side. So in that case, let's think about this, right? We don't really have to do a whole lot of work. If we differentiate both sides, we would just get just differentiate the whole thing. We would get 3 times dw on dt multiplied by dw on dt. This is equal to 6w dw on dt. So, already we have so much of this equation solved. We know dw on dt. We can just plug that value in. -2 times 3 is -6. Automatically, dl on dt is just equal to -6. That is a weirdly boxy 6. Why is that the case? Length is 3 times the width. The width is decreasing with regards to time at a rate of 2 inches a minute. We just multiplied -2 because it's decreasing by 3. We get -6. The length is decreasing at a rate of 6 inches a minute. Just off the fact that we can define the length as 3w. Now, if we follow through with the whole plugging in, we get -6 times well, okay, let's take a step back. Let's draw a picture for part 2 of this equation, since we are now looking for new part. Now we're looking for the area, which is dA on dt. Now, remember, we can define area as 3w squared that's equal to area. We know dw on dt, and we can differentiate that to get 6w times dw on dt. Now, when the problem states that the shorter side is just 6 inches, well, we can plug that into w, and we get L is equal to 18 inches, meaning this side have to be 18 inches. What do we do with that? Well, first we can find the total area of the of the rectangle. So length times width, 18 times 6, we get A equal to 108. Now, this wasn't super necessary since, well, part of this equation right here is really the only thing we need. So let's look at that. 6w dw on dt. What do we know? We know w. W is 6. So we multiply that, we get 36. We also know dw on dt. That's negative 2. So we multiply these two out, we get negative 72. Now, think about this. The answer is negative. That automatically is good. If it were positive, that would mean the rectangle is expanding, which is not what we want if the sides are shrinking. So that's automatically, that already makes sense. Simultaneously, if we think about how we rewrote everything in terms of w, where length is 3w and area is 3w squared, by differentiating with regards to time, since the width is a function of time, it's decreasing with regards to time, we can, like I said, write this as 6w, dw, and dt, and then we just plug in the values we know, and we get negative 72. So, I don't have a good spot to write this. Let's do here. I don't know what that was going to be. dA on dt is in fact equal to negative 72. So those are our two answers here. So yeah, not a super in-depth or good explanation, but I hope it makes sense. Not a super rigorous definition, but I hope it makes sense within the context of the equations. You can sort of visualize what it looks like, or visualize what the answers mean. So yeah, with that being said, thank you for watching. I'll see you next time.